Okay, let's start with our pop quiz for this month's Sacramento Python user group. Brought to you by Mike Driscoll, Python versus Mouse, no, Snake versus Mouse, and countless other Python-based publications. Number 21, fun with walruses.py. So what is the output of the print function? So we've got funny looking set of instructions here in paren a walrus operator 6 comma 9. So first and foremost, the walrus operator is an assignment value in an evaluation, I believe. uh, and basically we are printing a tuple, but we're also assigning a value to a variable that is a part of said tuple in the same go. I think one other way that walrus operators ends up getting utilized is one can assign a value to one of many variables in like a logical expression. So I don't know. As I was saying before we got started on the recording, I believe this is what led to Guido's eventual departure from the Python organization. But we have a few guesses wagered here. One's saying it's an exception. We've got to vote for A. Um, we've got people saying this isn't legal Python. I think it might be. I think we got another vote for A there. Let's see. Yeah. All right. Well, easiest way to do these things, let's go to a REPL like we do. So without further ado, I'm going to switch over to that. I've got it lined up so we don't have to spend too much time on it. So we got the first two lines already in there. Our quiz tonight is about the last line, but that first one, it's a tuple. So we're effectively getting that instruction evaluates to the tuple 6 comma 9. And so now we're taking A, which is assigned to the value of 6 at this point, and we are then assigning, or I guess we're printing another tuple now. So we're printing A, whatever its value is, which is 6, and then B, which has no value, but we're establishing a value as we are printing it. So now B is equal to 16, and then 19. So that tuple, 6, 16, 19. And then finally, we've got an F, like what is that called? A format string or something like that. In any case, we know that we're going to be substituting values for the variables that are inside the paren there, that being the A and the B. I hear someone in the background. Sounds like DN.
F string.
F string, there we go. Yeah. Uh, so any further wagers as to where this is going to end up? All right. And there we have it. A6, B16. So if you chose, wait, let's switch back. And so D, A6, B16. So the walrus operator, that's really the main one here. You're basically evaluating something while assigning a value to a variable within the expression being evaluated. So I feel like I've mostly seen walrus operators being demonstrated within logical expressions, but it's kind of an interesting one. Definitely gave me a bit of a headache looking at it. All right. Well, good one, Mike. Always fun going through your brain teasers. Little lulls before we get going. Yeah. Harry Potter. All right, welcome everyone. It is not 2024, it's 2025. I don't know what's going on with that. Sorry. It's a new year. It is it's now the start of my 5th year running this meetup. Good times. Still shoddy quality control. But we are over 1,800 members now. Does anyone know how to set up a toll-free number? 1-800 SacPy. Call us for free Python since 2017, thanks to Josh Miller. Where are you, Josh? Import Josh. All right, so it's Q1 of 2025. I like to do a look back on the past quarter for where I've been and what I've been doing and interesting stuff I think worth sharing. I went to Virginia Beach twice last year, and the second time was in the fourth quarter, so I have some updates there. If you're following along in the Brazen Studios Discord, anyway, some of us ended up going through the TOPS program with NASA. It was fairly lightweight, but it was run by a guy that presented, Cameron Riddell from Don't Use This Code. More about that later, but it's pretty cool. Been going back and forth with DN too on some stuff with the New Zealand group in Denver at the moment, or right around the corner rather. Some stuff there. Spent a little time in San Francisco and saw some cool things. Did some doodles for SacPy and got to spend a good amount of time at Shade Twinkles. So Virginia Beach Part 2. Oh, there we go. Oh, we're like going off. That's kind of funny. Anyway, yeah, so this is my friend at the bottom right there, Dr. Joe Moda, Esquire, a former Navy JAG. He's now general counsel at Oracle. Hung out with him this summer and then again in the fall. These are pictures from Virginia Beach, Chicks Beach to be specific, and that set of bridges there is Chesapeake Bridge. That's right over by Baltimore. It's in the Norfolk area. We started out this last trip with turning down the place and doing a deep clean. It's looking pretty good. I'd say it's almost Airbnb ready. Here's some of the setup we got going there. So I set up a whole bunch of furniture this time. He did a whole overhaul of things, so I was in IKEA mode for some time. Bottom right there, that's Maverick. He's enjoying the fair. Top right there is a company I learned about. That is what's called a challenge coin. And apparently that's big in the military. You finish, say, some operation and everyone involved is given a token. I don't know exactly how it works, but I think people put a lot of effort into designing them and they definitely put a whole lot of value in the ownership of them. And he had a pretty cool array of them. But the group's called Mermaid Metals and they're on Instagram, so check them out. And he had a bunch of funny art. He's a man of good taste. And while I was out there, I revived a project that I think I've talked about a number of times called Crap App. It keeps coming back. One of these days, we're going to get it off the ground. But yeah, Crap App. Maybe in 2025, we'll see. Checked out some of the art scene over on the ocean side in Virginia Beach. This was what was called the Liquid Art Festival. It was local brewery put on a thing and a bunch of local artists came and there were some live painters. There was a lot of things for sale and it's pretty neat. And I got to some art myself. There I was with my little recording setup that I made. It was one of the local performers. He runs a cover band. He's the lead singer, but also the drummer. And salt to the earth guy, but pretty phenomenal lyricist. But yeah, that's a funny little setup that I got there. So I set that up myself. I like to do a lot of DIY stuff. And when it comes to sound, often what it comes down to is dampening the sound in the room. There's a lot you can do digitally, but you can go a long way towards making a good recording if you can get a decent sound, a decent space to record in. And short of soundproofing an entire room, make a little box. So there's my little condenser mic inside the box. As you can see, it's not exactly factory standard there. I think that's maybe a $10 Walmart ring light and decent little 4K camera that I use. I think it's a Logitech or something. But what it amounts to is a decent little recording booth. I made this entirely out of packing materials. It's just an Amazon box and a whole bunch of packaging stuff. There's like bubble wrap, some of like cardboard stuffing stuff. And then I cut up a box and stuck folded up paper towels wrapped in toilet paper to make these little poofy balls and line the inside of the box. And it worked a treat. A little bit more on the technical end. In previous updates, I talked about going to Burning Man, and I realized I had a pretty good data set that I could apply to a technique called Gaussian splatting. And that is you take a video and it outputs a point cloud, or basically a three-dimensional navigable thing. So this was the tiny little point. My intention was to map a larger area so I could see the entire village that we had stayed in. I was in a cleanup crew, but it ended up that I just did a small sample and hit the road. It was done in Luma AI, and unfortunately, I don't have the actual interactable thing ready for tonight. It's on my phone, but here's a little video of it running. And so basically what I did was I took a video going around that thing and fed it into Luma AI, which is a mobile app. I think they have a Discord server. They may have an API as well, but it did some processing in the cloud and spat back out a thing that when I'm on my phone, you can like drag it around and zoom around it like you're flying around a 3D environment. Pretty impressive stuff. AI is here to stay, but are we here to stay on this slide or on to the next one? No. NASA tops. This was the one run by Cameron Riddell. It was. It seemed like mostly they were trying to preach to scientists to do open stuff. Us Pythonistas in attendance were like, yeah, duh. But that's Cameron on the left. He works for this group, Don't Use This Code, which was founded by a guy, James Powell, who has previously spoken with the group. And it was really sharp presentation on a whole bunch of ways to approach being open in the world of the internet and science, and talked a lot about reproducibility. Right, Ian? And we got a badge if you answered all the questions. I feel like the badge was really more about if you were in your seat when the quizzes came through, because they gave you these narrow windows to answer. And if you were paying attention at all, I think it was pretty much impossible to fail, but pretty cool. Now I have a NASA badge.
Well, I passed as well, so it must have been really easy.
Yeah, well, I mean, I passed. Come on. Apparently, if you filled out some of the right forms, you'd get some stickers and stuff. I don't think I figured that one out right, but whoever this is, Dora Saidi did. So maybe that can be done as ex post facto. I want some of those stickers though. Those are sweet. Also, they did that thing with the starship and they caught it with the chopsticks. That was really cool. I don't know if anyone watched that, but space is fascinating. I did some dolly work too. Just playing around. I'm working on this game called the Red Eye game. Been designing it for quite some time. It's been in anticipation of AI and a handful of other technologies taking off. Still a few pillars that I'm waiting to be built, but we're getting pretty close to be able to do all the computer vision stuff. But one of the things was character customization. So I wanted to borrow from a concept that comes out of Scottish culture called tartan. It's a basically plaid, but it's personalized. And so I gave a simple plaid pattern to Dolly and said, hey, give me some variants on this pattern. And this one was dedicated to my cousin's daughter. This was like a birthday project once upon a time, but I realized we could finally do some of the things that I was thinking. Um, Once upon a time, TensorFlow was out open sourced like November or something like that, 2015. And a group came out really quickly that did this thing. It was like do a sketch and flesh it out into a relatively photorealistic picture. I think it's called affine layer is a technique or something like that. But that one showed me that there's going to be a lot to be said for giving a schematic and requesting something more fleshed out. And I thought some of these look kind of cool. But yeah, the idea would be this particular character has chosen this tartan, and therefore, like when they have certain elements of their to like adornment of their character, they'll incorporate their own tartan. And so anyone who knows this person should be able to see them above the crowd. So been collaborating a bit on the Brazen Studios Discord channel. I'm realizing I sent the link to a fairly broken onboarding form. You might be able to get onto the Discord from there, but I'm going to put a more direct invite right now in the link because things have been getting fun. Where more and more people are chatting in the Discord, and I tend to I tend to post a lot, so it's kind of nice to have people going back and forth. But we've been talking about logos and stuff like that. And DN said, "Hey, we're working on a New Zealand one." And then, he's a pretty worldly guy, so he's also talking about just a pure online one. That's yeah, I don't know. Good stuff. So messing around with the logos, I'm trying to figure out what it means to be Kiwi at a glance. And what did we basically arrived at the fern leaf or something, Deanne? Currently it's like an upside down kiwi.
Yeah, except we're not really looking for the New Zealand one. We're looking for the online group one.
Oh, okay. The point being, I was just doing
Yeah,
a whole
the,
bunch.
the New Zealand one is the bottom right hand corner currently.
No, okay. Yeah. Well, then we'll just focus on the online one. Try and mash up some elements from like Internet Society or something like that. I don't know, but been
Oh, I
fun.
like the headset.
Oh yeah. Oh yeah, yeah. Dang, I should have put that one on there. I put this one together too. It's like Pacific Python. You don't often see this view of the globe, Pacific Ocean just being a whole bunch of emptiness, but not. Anyway, moving on.
It's all quality, not quantity, Woody.
That's true. So I'm currently out in Colorado with my friend here, but I was out here for his birthday in October, and we got to do some of his favorite stuff. I was hanging out at his humble abode there in this top two. We went and did a kind of top golf thing at the adapted Rockies Stadium. Rockies being in the off season, they had the stadium still ready to go, or rather, not being in the off season. The stadium was still ready to go, so they had the staff working and people coming through, and you got to hit balls onto the field. It was really cool. They had tee off spots from all around the stadium. It's good stuff. We swam together back in the day. It's keeping it together over the years. Did a little art photography last time I was in San Francisco. Went to this art gala. It was pretty neat. Bunch of exhibitions. Nice sculptural, but and a bunch of cool street art. If you're gonna vandalize something, I guess might as well make it cheeky. San Francisco sometimes has some pretty cheeky artists. Did a doodle for the SacPy thing. I want to do more of this stuff because I do like keeping my art skills alive, but it's also kind of like the Google Doodle. Maybe I could do one for other holidays. What do we got coming up? Do one for Valentine's Day or something. And then Shade Twinkles. I was hanging out with Taneem and Twinkles for like the last 2 months or so, and it was pretty cool. Livermore is a pretty chill place. Twinkles, Twinkles runs a tight ship, let me tell you. He does not suffer fools lightly. Um, yeah. I went in there just a pile of clay, and I came out just sculpted under Twinkle's harsh tutelage. And we did a little. I did some. I like to do doodles of my friends. And Twinkle's is my friend. Also, there's a very long budgie. I like fixing stuff when I'm around at my friends' places. And here's us getting set up at the battle station. I even put it to some good use myself.
There you go.
And that's basically Taneem in a nutshell. They're set up
There
over on Starflower. And so I worked a little bit on my website while I was out there. Uh, I was in science territory, so I figured I should do my resume in LaTeX. So looked kind of cool. It's a little bit better. I also worked a little bit on, I'm just working on presenting my offering a little bit better. Times they be a changing. And Travis Oliphant, the creator of NumPy, Anaconda, SciPy, everything under the sun that's awesome that runs things these days, he gave a pretty good one-shot look at what he's done in Python. I thought that was pretty neat, so I did the same thing myself. It came out okay. And then that's the goal, just be able to throw my brand up on a car for tax purposes or something. I made a little rubber ducky thing in GPT and rebranded it after Twinkles. You can check it out. Now, I know rubber ducking is you're just supposed to explain line by line a piece of code to an inanimate object because it's forcing you to frame up your understanding of the problem in such a way that you can actually explain it. But in this case, it's basically designed to ask you leading questions based on a whole bunch of approved software development lifecycle methodologies. MIT did a decentralized AI summit thing. It was kind of cool. It was definitely more bizarre than Cathedral. A lot of people shelling. Pretty neat though. The round table at the end was awesome. I think that guy on the bottom right is a pirate. And then I always make food places. So we did some chicken, made some guac, stopping at my old video game friend's place in Ventura. I think they're probably completely inundated by smoke right now with the fires, but hung out with him, made some guac, other things. All right, that was my quarterly one day. My accountants will thank me for being so diligent to warm up, but for now, the main event. Christian Nuss.
You forgot to mention your contribution to the Python Learners Co-op, which has been much appreciated.
Oh, yeah. Dan runs a group in Auckland, but he also runs a group that's dedicated to just sort of collaborative learning. It's kind of funny because, well, I think us Pythonistas are kind of lifelong learners in general, but the group has a bunch of people trying to learn, but it also has about as many mentors. So it's kind of fun because fairly high level talk, but then it's like a whole bunch of people teaching each other. It's a neat group. I think there's something there. Like when we get the formula figured out for it, that could be pretty valuable. But Deanna, if you want to drop a link in the chat for anyone who wants to join up in future ones, I know you talked about this being, you know, exclusive in terms of volume and whatnot, but there we go. He's got a email there. Deanne's a good bloke. All right, but without further ado, I want to introduce Christian. We are well into the hour, and so I want to give him the rest of the time to show us what he's doing with LLMs in the serverless cloud. Kristen and I go back to San Francisco. We were in a multi-sport league together. It was good times. We worked hard and we played hard. And Christian has always been one of my more enterprising developer friends that I actually never like worked with him in a development capacity. We just hung out. But he runs a company or a product called Scaffoldly, and I think he's going to talk a bit about that tonight. That's his logo there. But I'm going to hand the share off to Christian. Christian, thanks for coming tonight, and
Yeah, thank you.
everyone strap in.
Yeah, buckle up. It's gonna be a wild ride.
Yeah.
Yeah, Woody and I go, yeah, it's way back. Was it a drinking league or a sports league?
That was the joke. Yes, a drinking league with a sports problem.
Yeah, nobody knows. But it
Yeah,
definitely, it took years off my life, but we definitely became flip cup experts at it. So
that's true. Yeah,
yeah, I'm still unbeatable to this day.
yeah. It's like riding a bicycle or something. Once you get the muscle memory, or
Yeah, it was a great way to let loose on the weekends, but it was on Sundays, so a terrible way to start Mondays,
yeah.
because basically we had 4-day work weeks just because we were so useless on Mondays because of the hangover.
Yeah. I think I may or may
So
not.
that's where the 4-day work week came from, and it needs to be added to Wikipedia if it
That's
needs
right.
some. Yeah, so since this is being recorded and put on the internet, if someone can cite that and add it to the Wikipedia. That's when the Bay Area invented the idea of the 4-day work week is because of our uselessness on Mondays.
So you're welcome.
Yeah.
What we do out there in San Francisco,
Yeah.
innovate.
So let me introduce myself. Thanks for having me. I made a post a little while back on Dev 2. About running models from Hugging Face in AWS Lambda. And that came across, I posted on LinkedIn, and Woody found that interesting and thought I should speak here. And I'm very excited to, yeah, be chatting with everybody. I do like this to be interactive, and I'm going to be sharing my screen. So if you have any questions, just unmute and yell them out. Interrupt me, please. Uh, and I'm going to start it off with a little bit of my background, but I also want to ask about a few of the people here in the room. Um, so I've been through the ringer of a handful of different layers of the stack. I started my career right after college at Purdue. Worked at Comcast and like the Xfinity boxes you have in your houses if you still have the cable. Basically, I was on the team that wrote the first version of that, and so that was my that was software engineering. And then I hopped over to a company where I did database engineering for a payments company, and they basically were doing pay by mobile. And then I hopped on over to a healthcare company and was basically it was when Docker and containers were brand new. Kubernetes didn't even exist at that point in time, so we had to write a Kubernetes like way of orchestrating containers, and it was crazy, and it was in the public cloud, and it was private personal health data, so it had to be secure. So we were like encrypting stuff using, tech from God only from the late 90s, early 2000s in AWS. That was crazy, but got really good at, orchestrating containers in the cloud. After that, I went and helped. I was a CTO for a health startup, and that one, it was fun. I was a hands-on CTO where with small cash strap team, and we ended up like having a mobile app, a back end. We had developers in South Africa and the United States. They had a wearable device, so I was all the way down working on firmware code sometimes on the React Native mobile app, sometimes on the front end. Sometimes it was React front end, sometimes it was that, and then also, setting up the DevOps and infrastructure pipeline. And since that was cash strapped, trying to find the most affordable ways to find and run stuff. And that's why, you'll notice a trend here is I like to find the affordable ways to run things. And so like that company was built with zero Kubernetes, even though Kubernetes was there. But Kubernetes is a great way to burn money, in my opinion. But we could save that for a topic for another day. Um, and then after that, then the company's Scaffoldly product that I worked on, I moonlighted on that for a little bit. At the same time, I started working for a big data startup that was doing a security data lake. That was all in Kubernetes, and they wanted a smooth, seamless DevOps pipeline. And I'm sure you, as Python engineers, know that running big data in the cloud is quite hard, and a lot of the infrastructure and things that are built out there just are really, really, really bad with large data sets. And you like need a really big team to run that. Um, and now I do two things. I am trying to start my own company slash open source tool called Scaffoldly. And at the same time, I'm working on a company that's basically orchestrating Kubernetes a lot. Our primary client's Ashley Furniture, and we just basically print Kubernetes clusters and all the automation behind it. Um, and so yeah, that's basically my background. I'd like to get so to go back on the topic at hand here is kind of what got me down this path is I've always been a huge fan of serverless workloads. Like ever since AWS introduced AWS Lambda in I think it was 2016, correct me if I'm wrong. Or maybe it was earlier. Was it 2012? Anybody know?
Looks like
Some
it's 2014.
2014? Okay. That sounds about right. I think I was at that AWS reInvent and my mind was blown. I was like, this is gonna change the world. And it hasn't had the level of adoption that I thought it was going to. But I've always embraced the concepts and functionality of it. Um, to kind of get a like show in the room, like who's dabbled in serverless before or serverless workloads, Lambda, cloud functions, whether it's at your work, personal, or anything like that?
A little bit. I made like was that cat facts with Twilio?
Okay. Can you describe like or can you describe like what that experience was like just like emotionally?
Well, it definitely did not include as much toil in setting up the actual metal of the
Hmm.
metal setup. You don't have to configure a gateway or anything like that. You're just kind of dumping an existing script into the thing, and it's like plugged into the rest of the serving experience. It's just like
Hmm.
you go straight to the actual algorithmic thing you're trying to do. You're like, I want to do Twilio. I don't want to like set up a whole bunch of bash scripts or something.
Hmm. Yeah, and it's like really good at like if you have a handful of lines of code and you need to run it and it works great. Um, I started hitting some frustrations around serverless when it came to like dependencies. Like I wanted to be able to package something that felt more like a traditional application that I was writing on my laptop, an API server. And I want to be able to run that in Lambda, be able to like write an Express app or write a Flask app and be able to push that over to Lambda or push that up to AWS Lambda or something else. And so where I got where I am now is I was like, that was really hard. And there's frameworks out there, the company's called serverless, the CLI is called serverless, but the foundational technology is also called serverless. A little bit of they got the name really, and they really helped. I feel like I cracked the case back a while ago when it was able to get an Express JS app compiled and run and pushed over to Lambda, so it felt like I was writing an Express app locally. And I press a deploy button, and it's up and running in AWS Lambda, uh, and uh, and basically fires up, runs my endpoint, or AWS fires it up, runs that endpoint, and then it shuts down eventually. I thought that was a really cool thing, and I'm like, this is really useful. And then I got to the point where I'm sure you guys have heard of like Next.js and Vercel, for example. I got to the point where I had a customer client that was like, "Hey, I want to run this Next.js application in AWS Lambda." Well, I got to the point and I found out that the Next.js binary, AWS Lambda has some pretty stringent size limitations on the code bundle that you can push up to it. And I think a lot of the cloud providers do as well. Like your code and its dependencies out of the box needs to be less than 250 megabytes. And I quickly found that the Next.js, as soon as I tried to bundle that and push it up there, it was roughly almost a gigabyte. So that was like, oh well, this won't work out there. So what do I do? So it led me down a rabbit hole to find out how to do that. And I ended up finding out that in AWS Lambda specifically, you can actually build, you can tell Lambda instead of running a a script and it running that script for you on container, you can actually build the container and tell Lambda just to run that container. So it's very if you've run Kubernetes before, it's a lot like firing a pod, doing one thing, and then having that pod turn off as soon as that one thing is done. And as soon as that happened, I was like, oh my God, the possibilities are endless here because everything out there is event driven. So even an API endpoint coming in from the internet is an event. And AWS and other Google Cloud Functions and everything, they've all made it really easy to basically they host the endpoint up there for you, the HTTPS kind of colon / my API.com. And then so that's always online, and they take care of hosting that for you. And then as soon as that comes in, the way Lambda works is they basically take that event, which is an HTTP request, and they hold on to that socket, basically send that payload down to a work queue, and basically is in that work queue, it fires up a container sends that message into it sends that message in the container. The container does something with it, sends a response, and then sends that back, and that goes back to the requester. So it's all an event, and that's basically how like AWS Lambda works. Um, Now, what's interesting about the AWS Lambda doing the container thing is that's how I was able to get beyond the 250 megabyte limit. However, AWS adds some really interesting artificial boundaries around that, where the container you have to run needs to come from their container registry. Like you can't run one of their things. And so I'm probably just going off at a tangent on how serverless works, but I'll get into the machine learning model bit here. Um, is there any questions or comments on or disagreements on anything that I've said so far?
Well, one of the things I know about Lambda is that it's billed at per millisecond.
Yeah.
So what do you think about like how do you approach maintaining like reasonable cost effectiveness? Like that's got to be pretty closely managed, right?
So let me contrast that with something else. If you write a Flask application and just a basic API and push that up to an EC2 instance or a Kubernetes cluster, for example, that backend, that API is up and running, whether it's serving traffic or not. So you're paying for it consistently. And this is where serverless gets a bad rap is it's like unlimited billing, for example. However, if you have a an API that is, it could be often invoked or seldomly invoked, or whatever, but you're only paying for it for while you are doing active compute. So if you write your API endpoints to be quick and return quickly, and you don't spend a whole lot of time long polling or doing bad database long database queries and stuff like that. You come up, you serve your request, it shuts down. All that other time you're not paying for and AWS is incurring the cost of running servers, not you. You're only paying for the time for which you use, and then you're gone. Whereas like Kubernetes or a container system, your workload is always up and running, whether you're getting traffic or not. And that's where a lot of the cost spend of non-serverless comes from. Um,
So, but basically, the reusability is gone, right? Let's say when we are writing some software and putting it in Lambda, let's say if there is a server, we can reuse the same service for multiple times. Whereas, in Lambda, when you are saying the workload should be seldom, right? So
Not exactly. So I actually have a few things that I've launched in my recent history that are running on Lambda, and I basically wrote APIs, pushed those up to Lambda, and so just to give you an example, that product today gets about 4,000 requests a day, and that's including with my pipelines that track the database. And so it gets 4 requests a day, or 4,000 requests a day, and my AWS bill on that product's about $4 a month.
Not bad.
Not bad at all.
But what is the reason if you are getting $4,000 4,000 requests per day? Is it wise to host a server or is it wise to host a Lambda in that case?
I would say if you're able to so far I've gotten to the point where I don't even want to host a server because like if I fired up an EC2 instance or a Kubernetes cluster, like let's say I fire up a Kubernetes cluster in AWS and launch a container and I have zero traffic. That's going to cost me at least $200 to $400 a month out of the box.
Mm.
If I fire up a Fargate container, that's going to cost me at least $30 a month and have zero scale behind it. If I push the code to Lambda, it'll be up there and available, and it can serve out of the box. AWS can let you do 1,000 concurrent requests, uh, and that's active compute. And that's active concurrent compute at a single moment in time. And then you're only charged for those seconds. So you get unlimited scale. You basically get unlimited scale, um, and at fractions of the cost of normal compute.
Yeah, it's building on the shoulders of giants.
Yeah. So I feel like I've cracked the case a little bit. Towards the end of this, I'll show you some of the other things, but I do want to focus on the machine learning bit here. But I kind of wanted to give you my preference and background on serverless and why I really like it. Because I could launch a whole bunch of products for really, really cheap, and I don't have to pay Vercel. I don't have to pay like I have to pay Vercel for a whole bunch of things, or the stupid front end. Or to this framework, it would cost me about 12 cents a day to run.
Nice.
Adit's asking about how does this compare to Redshift or Snowflake? I don't know about Redshift, but I know Snowflake is a lot more strictly database oriented. But
So so Redshift does have a serverless component, and Snowflake does have a serverless component. Um, Let me talk on Snowflake, for example, because it's a little more advanced and cool than Redshift. Snowflake, for example, when you run a database query, yeah, what they do is the exact same thing, where they have a whole bunch of basic servers out there that are ready to run workloads. You take a SQL query, and it basically spreads out that SQL query across many event queues, and then goes and fetches the data for that small little thing, and then joins it all at the end and returns it as SQL. And then each one of those like fetches from a data store runs as serverless. So it's these really tiny workloads. So you get this really large scale from this really large pool of idle compute, and then it ends up running something and then shutting down. So yeah, uh, you're right on the nail. You hit the nail on the head. The database workloads are exactly the same. There's APIs, there's databases, and then the cloud providers have gone and optimized their cost for this and turned it into a product, because they found that if you can crack the code on running serverless, you can actually charge just as much for your product, but run at fractions of the cost. And actually, yeah, Google Cloud has cloud functions as well, which cloud functions are akin to AWS Lambda. And like I think AWS Lambda was first out there, and then Azure has theirs, and Google has theirs. Cloudflare has theirs. Everyone has it. Uh, but as we're going to see here, that I'm going to show off a little bit, is they don't make it easy. And that's what I'm trying to do with Scaffoldly, is try to make it easy so that everybody can kind of embrace serverless, but not have to diverge from their regular way of thinking about developing an application. Question is the benefit that Lambda is way cheaper as Snowflake has a really built tools? Yeah, because what Snowflake has done is all you have to do is check a little checkbox that says, "Yeah, run my data warehouse, or run my data warehouse as serverless." I'm probably oversimplifying that, but and they'll charge you and they'll charge you for active work. And if you're not using your Snowflake cluster, you don't have to pay for it, or you have to pay for the data storage or something like that. Um, and Snowflake has done a really good job where you still get this screen on the page where it says you type in your SQL query, and your compute still isn't up, and then as soon as you press that run query button, then an entire Snowflake backend fires up. They spread out they spread out the serverless functions that are running, and then join all the results at the end, and then return it back to you. You have no idea that it was a serverless distributed execution, but it still was, and that's probably why that's probably why it's so nice. So if you can actually crack the code on how to run it well, you can really make your economics good. Um, and so like when I was CTO for that health startup and we were cash strapped, that's when I first cracked the code, and we were able to run the entire infrastructure on AWS for like I think it was $40 a month, and we never had downtime. We never had an outage. We never had a limitation on the number of users we had, and $40 a month to run a full company on AWS. So that's my bit on serverless and my that's my bit on serverless. And so my goal here is kind of like I'm trying to make it easy for the rest of the world to do the rest of the world to embrace serverless. It's slow. Um, and so I wrote this toolkit called Scaffoldly, and as soon as I finished it, at the same time at my full-time job with Ashley Furniture, they wanted to start running AI workloads and everything. So I had to dive into like what the process of running uh, AI models was like. So that's when I was first introduced to Hugging Face because they wanted to basically launch a ChatGPT clone, but run it in our infrastructure. So I was on the team to do that, and then I was also writing Scaffoldly at the time. And as soon as I pulled apart the layers, I was like, "Oh my God, I can run machine learning models serverless. I can do this exact same thing that I designed to do APIs. I can also basically pack in machine learning models in the same way." So let me give you a rundown on Hugging Face here. Is uh, And so I'm going to share my screen and kind of and click around. So if you guys have any questions, I'm not going to be looking at the chat. So please unmute and just ask questions, or Woody, keep a beat on it. Um, so to put Hugging Face in Python-y terms, it's like PyPy, but for machine learning models. And it's how you can do pip install requests, for example. You can also do Hugging Face download 5.4, and then they also or fee4, and they also Hugging Face is also provided. They're very Python-y. They're Python first. But they do have some JavaScript libraries and stuff like that. But if you want to run a model, it looks exactly like this. It's just Python. However, there's a lot happening below the covers here. Like when you do import transformers, that's just their library. However, if you go into the code for transformers and you're like, hey, I want to run this pipeline and the model's 5.4, fee4, whatever. Um, it will actually go, and similar to PyPy, where you pip install, it's going to download the wheels into your local virtual environment and then keep those on the side so they can be executed later. When you run this pipeline, the same thing happens in Hugging Face, where it goes out to Hugging Face and pulls the Microsoft 5.4 onto your local system, keeps it there idle until you run a command like pipeline, and then this is where your how should I explain the internet command goes into a model. And basically it goes through pipeline. As soon as it goes through pipeline, if you dig through this code, at one point in time, you get into the download, blah, 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 the download dependency stage, just like the pip install or poetry ad, for example. But they do it in real time. Why do they do it in real time? Let's go take a look at Microsoft 5.4. These models are huge. So if you go through here, there are 1, 2, 3, 4, 5, 6 5 gigabyte files, uh, and uh, and that's pretty big. So imagine doing a pip install of something and it tries to download 20 gigabytes worth of stuff. That's basically the ecosystem that is machine learning models. You got these 10, 20, 30 gigabyte model files. They all end up basically looking like a single executable on your system. And the interface to them is, some Python right here that goes and downloads it and fetch that stores it on your system. And that's why a lot of people complain that ML is so expensive, is that these models are very, very large and they have to run on computers with very, very large CPUs. From what I've heard, the generalized thing is, if you have a model that is like this one, which is 20, what was it, 6 times 5, so 30 gigabytes in size, you need to run it on a system that has 30 gigabytes of RAM. So you need to be able to fit the full model in memory to be able to run it. And so that's a lot why machine learning is so expensive. Or like why they say OpenAI or ChatGPT costs so much money. It's because of this. Um, and then I haven't pulled apart the covers very much here, especially in this world. But my theory is that the way OpenAI ChatGPT sets it up is they have their same model set up and running cold on a whole bunch of servers that's available on disk, and they have a whole bunch of servers can fit their model into memory. And when you ask a question, it's going to fan out that request to a whole fleet of servers. All of them are going to collectively answer that, and they're going to, once again, similar to the Snowflake model, where you're running a query and it's sending the requests against a whole fleet of servers and then joining the response and sending the response back to you. It's not that different than a database query, but the thing is that all the database they're running against is very large and all file based. Like if you look at the underpinnings of Hugging Face, it's basically Git underneath the covers. So if we go look at the files and revisions, and it's like, okay, so let me get to a example that I wanted to show you guys to get started. Is I went and let me get my link here. I found this post from a while ago, and it was 2021, and AWS came up with a blog post on how to run a Hugging Face model in Lambda. I actually found this after I put everything together, and just kind of wanted to highlight, what this code did. So here I have it cloned, and let me make this a little bigger so you guys can see. So this is built with the AWS CDK. If you look at the README, the way you're supposed to deploy it is say you install your requirements, then you do CDK bootstrap as CDK deploy. And then there's two parts to it, is that there's the app.py, which sets up your AWS infrastructure, and this one line sets up a VPC. Okay, cool. And then it sets up a file system, and then it sets up a Docker folder. And once again, all of this that you're looking at has nothing to do with actually running the function. And then there is a Docker file, which basically, builds a build. It takes your code, puts it into a Docker container, and then back in the app.py, after it's built, it pushes that container up to Lambda with some settings, and basically, mounts up the stuff. And then your actual workload here is the sentiment analysis, and the whole goal is to get the sentiment analysis pipeline. This pipeline function, once again, underneath these covers, it's going to go do the download from Hugging Face, download this model called sentiment analysis, and run handler. And so basically, the first thing I saw out of here is there's the Docker file, there's app.py, CDK JSON, all of these things that have absolutely nothing to do with running this. So basically, you have all this scaffolding to run 16 lines of code. And I'm like, that's nuts. Um, so what I assume people do in the like if you wanted to run things locally, or if you wanted to like develop and run a thing locally, and it's like I want to be behind an API, and I go over to Hugging Face, and like Hugging Face I'm on here, and it has the ability to sorry, I got to get Zoom out of the way. Let's go to the one I'm actually going to demonstrate here is OpenAI Community GPT-2. So you have the ability here to invoke it via the inference API, which basically says, hey, import requests and just make an API call to it and runs on their infrastructure. But the question is, what if you want to run it on your own? What if you've made your own model, you haven't pushed a Hugging Face, or you made or you've taken this model and retrained it and it's up on Hugging Face and you want to run it on your own, but you don't want to pay Hugging Face for it? And then also in the other world, there's AWS Bedrock where you can go take their very small set of available models out there and run it. There's also I believe Cloudflare also has this, but once again, its own weird syntax where it has async fetch. Like, where's the entry point for this? How do I run it locally? Like all of these things, like as an engineer, I'm really frustrated about. And I'm like, when I see env AI run, and it's like, what does the come on? Like it's so abstracted away, more friendly to me. So, what I'm going to show you here is just a quick little bootstrap of a brand new project that you probably in a format that you guys are going to be pretty familiar with. Before I continue, does anybody have any questions?
So one thing I see is you are running the pipeline and you are saying that it is automatically downloading from the Hugging Face, right? So
Correct.
and see, we can't run a complex model like this, right? Like let's say we have some complex model structures or RAG models or something which is picking from our local database and running it. How does these kind of things will fit here? I'm trying to understand.
How do these things, sorry, one more time?
No, basically, what you are showcasing is basically you are running a foundation model, right? Existing foundation model, you are taking and running it. So how does a custom made a custom model, right? A model RAG model which is built on the foundation model will work out, right? I was trying to understand that.
Uh, I would love, so this is still a part that I am unfamiliar with in what what that is. But I do know theoretically that if you can get it repackaged up and pushed to either your own private registry, either whether it's Hugging Face or Get LFS, uh, uh, it's and the Hugging Face pipeline dependency can pull yours. Uh, it all should just work. And unfortunately, I don't know much about that side of the pipeline, but I do kind of see it as a DevOps problem as well. But that's kind of why I threw this out there is I do want to see that side of the ecosystem where you take the foundational model and retrain it and make a new private model, and maybe you don't want to share it with the world. I do want to see what that side of the ecosystem looks like. So if any of you guys have experience taking a foundational model doing that, I'd love to pick your brain so I can continue to iterate on this.
Sure.
So we're going to start with foundational models though here.
Thank you.
Let me get my notes up here so I don't go off on a tangent here. So you're gonna see stuff that's pretty standard. I'm gonna build a poetry project that has Flask and it does the and it pulls the OpenAI Community GPT-2, wraps it in an API, and returns it in a web browser. So that's what we're gonna build really quick. Um, And then finally, I'll push that up to Lambda. So let's do poetry new, SacPy, GPT, and then SacPy GPT, and we want to do, I'm going to do a poetry config, get that virtual environment in my local thing, so VS Code's happy. And then let's do poetry, add Flask. And let's go ahead and open this in VS Code. And then let's do what we always do is let's just go look at Flask and steal their example. And let's just make our simple app, yada, yada, yada. And then back in VS Code, let's just make app py. Paste that in. And just make sure everything's working here. Poetry, run, Flask. Cool. Hey, all right, my hello world's up. Awesome. Now let's actually make this. So once again, back up. My goal is in Hugging Face, you have this deploy command, and the goal is I want my own endpoint that's not hosted by Hugging Face, and that's where we're going. So right now all we have is something that just says hello world. So let's continue down the let's continue our march, and if you scroll through Hugging Face, it's going to be like, okay, this is how you use it. You do import transformers and create generator and run generator, and it returns a list of objects. So let's go ahead and do that. I'm going to pick a few pieces out of here and add that. And let's do poetry, add transformers. Cool. Downloaded a whole bunch of stuff, including Hugging Face Hub. This is the magic dependency that goes and downloads stuff. We're going to add that import, and let's make our generator. We'll just do that up here. The reason I'm doing it up here is because that means it'll when this pipeline command runs, I've dug through the code. When this pipeline function runs, that's when you get all deep into the Hugging Face thing where it actually does the downloading of the model and the caching of the model. So typically you want to do that outside of your API endpoints because you want your API endpoints to quote unquote stay fast. I usually call fast anything that's 30 seconds or less. And then let's go ahead and switch out my hello world with this generator. And let's go ahead and rerun that and poetry run, Flask run. We're gonna be like, oh crap, we got a big fat error. And ignoring all this, they made it look really scary. I don't know why, but they're just saying, hey, PyTorch isn't added. So let's just do a poetry, add torch. And this is where things get really interesting because torch is a fatty. And torch also, if you dig into torch, it has specific builds. It checks to your OS to see if it's Mac, Linux, Windows, and downloads different binaries underneath the covers. It's pretty interesting underneath the covers. All right, so we got torch. So let's go and try running this again. Now, because we ran this, generators out in the global scope, this is why it's starting to download stuff now. So we're just going to wait a little bit. Cool. Let's go and hop on over there. And there we go. It just ran the model, and it's very similar to what was here, and it was very similar to what was here, but it's deployed. It's very similar, but it's now localhost / that. So technically, we're kind of doing the same thing Hugging Face Inference API is doing here, but now on our local. Excuse me. So now the question is, I'm ready to make this available to the world. Like I want to host it on HTTP endpoint and be able to send it to one of my coworkers or someone else to run on, or I want to build my own web app that basically runs this. And you're like, okay, so do I go? But the problem is that you wrote it in Flask, and this is not the format that Lambda or any other serverless framework expects. So that's why I wrote a toolkit called Scaffoldly, is so you can have very familiar application constructs, but also run anything that you want. Um, I've built it to support PyProject TOML here, and I'm going to steal some config here that I prepared, but I'll go through this line by line and explain kind of what it is. So we're going to add this here. Yeah, let me clean that up here. All right. So, in your PyProject TOML, you can add tool.scaffoldly, and you say the runtime you want it to run on, Python 3.12. Boom, boom. These guys match. What's your handler? Localhost 500. Oh, yep. Local 127.0.0.1 500. Same, only different. What packages do I want installed? Well, the only thing that I know that's not going to be in Python 3.12 that I need is poetry. So let's go ahead and install that. I'll come back to resources in a minute. I'll come back to schedules in a minute. All right, and then what are we building? Once again, Python 3.12. It's also going to need poetry. And what needs to come out of this application that needs to be packed into that actually that actually needs to live up there. So of everything in my project here, what actually needs to go up and live in the cloud? Well, that's my VM. That's poetry lock, PyProject TOML, and my app.py. That's basically everything that matters. And then what scripts do I need to run? Well, first thing I need to do is run prepare. So first thing I typically need to do is just do poetry config virtual and in project true. You noticed I ran that here. And then the next thing I do on a like you think about this is if I'm taking a fresh brand new system with only Python installed, what I need to do to run my application. Cool. Let's do poetry installs the next thing, which will then pull everything. And then finally, how do I run my application? Oh, I ran poetry run Flask run. I'm actually going to nuke this poetry toml here because we're running the command. I wasn't supposed to run this. I was experimenting earlier. I wanted to run it as the prepare statement here, so it happens in the container. So let's take a look at this. And I'm sure a lot of you have fumbled around in Docker containers before. They were a huge learning curve for me. I would love to know what they're like for everybody else, but I think like they're great, but they're confusing is what I think. And often I'm like, there's enough information around your project that you can actually Docker container builds and the Docker file that are written are pretty predictable. And all you need is a few things to know to make a Docker container. So I've written a CLI called Scaffoldly. And let's just do the command, and you can do a handful of commands here. Let me just do help really quick. So I'm going to do Scaffoldly show Docker file. Let's do help here again so you can see that's a real command. So my goal here is like as an engineer writing a Flask application or a machine learning engineer just wanting to run a ML pipeline, you know all the commands that you need to run on your computer. Do you need to know how to write Docker files? No, you don't. You just want to be able to run this one thing. So the Scaffoldly CLI that I wrote basically builds you the Docker file based on this pretty simple syntax, and you'll see here that it's generating a Docker file. You'll see here that I said I want packages pip poetry. If I wanted to add pip requests here and then do show Docker file again, you'll see that where's requests get installed here? Or sorry. It should be somewhere. Oh, maybe I'm screwing something up there. But you can also install OS packages like curl, for example. So if you wanted curl installed on the system, you can see here that it'll automatically add the right command and install curl for you, which if you were crafting your Docker container on your own, you'd have to be like, okay, do I use apt? Do I use yum? Do I use DNF? Do I use that? What I made was my toolkit aware of what the package manager in this Python 3.12 container is. You don't have to worry about these stupid commands, and remember to RMRF and clean up your dependencies and slim up your container, for example. So the goal is just to like abstract things that the system already knows away from you. And so, yeah, this is an exact Docker file that you would run. Any kind of questions on that? The next thing I'm going to do is the Scaffoldly deploy command, which is going to go and package the Docker file and create Lambda functions and create all the primitives in AWS that need to exist, and basically put it on the internet.
So I have some questions as to where things live. So I see you running npx commands. So it looks like Scaffoldly is an npm or npx package. I'm not really sure because I'm not a JavaScript person. And those live on the developer machine, correct?
Yeah, so npx is just the shorthand world in the npx is shorthand in Node for npm install -g Scaffoldly, and then so the -g means install it globally, and then /scaffoldly.
So when you're inside the when we're inside the Scaffoldly package, npx is a like a macro for that. Is that correct?
Yeah, so I think of it like pipex,
Okay.
where it will download and run something for you in one command. And so I've had I like JavaScript, TypeScript, and stuff like that. So I opted to write Scaffoldly in TypeScript. So npx is just a nice way to run things in a CLI way without having. I didn't have to make a binary, but I could make a homebrew package which can set it up on your system as well.
Okay.
So ideally, like you could just do Scaffoldly show Docker file like that and have it installed as a proper binary on your system.
So I came in kind of late, but it I'm kind of wondering what. So it seems that the essence of Lambda is that you install all of these packages uh, onto this Lambda server, and then it knows how to swap them in and out as that gets cycled in and out. Is that correct?
So I package so the Scaffoldly the tool chain here basically creates a Docker container with everything you need in it, pushes that Docker container to AWS ECR, and while we're waiting on the deploy, while we do the first deploy, I'll go around and click through a few things to show you, and then it sets up the Lambda function to launch that container. And then the internals of Scaffoldly, like what like if I show this Docker container, if I do Scaffoldly show Docker container or show Docker file, there is a entry point that I bake in that basically is the interface. It's a proxy that takes in the turns that back into an HTTP request that I will run poetry, run Flask, run, and then route incoming requests to local host 5000. So
Okay.
basically a proxy that gets baked into the container.
So the ECR, the Elastic Container Registry, is the thing that you send the Docker containers to, right?
Correct.
Okay.
And the most annoying thing of Lambda is if you want to run a Docker container in Lambda, it has to come from ECR. You can't just run any arbitrary container. It has to come from ECR. I was like, well, that's also an annoying thing that's going to piss a lot of people off. So I was like, you know what? Why don't I automate those steps so you can easily go from a community container, which this one is coming from Docker Hub, add all your stuff to it, and then push it
Hmm.
up to ECR, and then wire that into ECR. And like if you were doing all these steps by hand, when I run the Scaffoldly deploy command, we'll go through a handful of things that we do here. It's like that's a lot of stuff you had to do. And also back in this project, you'll see a lot of these things in the app.py. These are a lot of prerequisite steps just to run 16 lines of code.
So ECR is the right way to deploy the Docker containers, but what are these wrong ways that you're comparing it to? Because having not actually done it myself, I don't really have a good sense for what the way that people might do it, as opposed to ECR, which is the right way.
The right way and wrong way are technically the corners that AWS paints you into for some reason. Sometimes they do a lot of things that make a lot of sense, sometimes they don't. There's two ways to get a Lambda function birthed, really. The first and most popular way is you have your app.py or you have your Python file.
Hmm.
All in all, this gets zipped up and sent up to Amazon S3 as a zip file. And then Lambda is informed that that zip file exists. And when it gets an event that comes in, it unzips it, packs it on the file system, and then it has a little middleware that basically turns it on and then invokes handler with event and then does this sort of stuff. There's a whole lot of magic that happens underneath the Lambda covers to make all this work, but that is happy path number one. However, they have size limitations around this where if this code plus everything in your virtual environment goes over 250 megabytes, they're going to tell you to go home. So if you want to exceed that 250 megabytes, you have to go into Docker land. So so you have to go make a Docker container, and then they paint you into the corner. Now, the first they paint you in the corner where you have to put your code to actually zip up your code and push it up to S3. That was uncomfortable corner number one. Uncomfortable corner number two with the Docker containers. And if you now have large dependencies like PyTorch, for example, which PyTorch is a fatty, way bigger than 250 megabytes by itself, not excluding your code.
Right?
Uh, uh, then they're like, okay, so now I have to learn Docker just to get this up and running. And then I also have to learn how to push to ECR just to get this up and running. It's really some uncomfortable corners they paint you into. Where it just took, like, for me on our side, like it should be just as easy as how fast I made this Flask application to run it. It should be just this easy to run in the cloud as it is to write it. And that's the big problem I'm trying to solve here is running it should be faster than writing it.
Hmm.
Let's go and get the feel free to interrupt with more questions. And I'm going to go and get the very first deploy going here. And let me go ahead and connect to AWS here. And we're going to do np X scaffoldly deploy. So let me just walk through here. Oh, go ahead.
So if I remember that number, it's 256 megabytes.
Yeah,
Is
roughly 250 megabytes. Yeah.
and so somehow all of your packages have to fit together under that limit.
Mm-hmm. And I can't remember if that's compressed or uncompressed, but it's pretty absurd.
Yeah, that's pretty small.
And
So
that was
yeah,
like
I don't see
that
how
works
you're
for a
gonna.
lot of things, but as soon as you add PyTorch, you're screwed. Or like even SciPy, or what are the other ones that a lot of people use all the time?
There's scikit-learn.
Scikit-learn, definitely. NumPy, also huge. Um, so it's just like like and I guarantee the authors of NumPy, the authors of scikit-learn, or the authors of Torch, they're not optimizing for this. They're like, we don't care. We don't care about these size limits. That's not our focus. We just need a really, really good library. And if it's fat because we're downloading a bunch of because we have a bunch of OS level binaries. I don't even know why NumPy is so I don't even know why PyTorch is so large. Actually, I do. It includes all the NVIDIA GPU binaries in it, which
Right.
sucks. But it's not their job to optimize that out and optimize for size. It's their job to optimize for inference and training.
That's one
They'll,
of the magic
they'll
tricks
get
that
there eventually.
Scaffoldly does, right?
Well, Scaffoldly sidesteps the problem.
So I have one question here. You are saying that you are deploying to AWS, right? Are you having your AWS configuration somewhere here?
Sorry?
You have your own AWS configuration here, which is deploying to your own AWS. How do you
Yeah.
configure that AWS here?
Oh, I have my own CLI to set up my credentials here.
Oh, got it. Okay.
It's the same thing as using like I could have run AWS configure or set up my AWS config, but I do it my own special way. Let me go through here really quick, all these steps that are going. Yeah, and these are all so I'm echoing out all these steps that you have to do to even get a Lambda function created. So you have to create an ECR repository, then you have to do a Docker build. I gave the benefit of secrets here. That's one choice I decided to do. Then you have to do all the linking up of the EFS access point. That equivalent over here in the AWS land is this create access point command. Once again, you're seeing as a machine learning engineer, Python developer that just wants to host an API. There's a whole bunch of confusing shit in here that you probably just like looking at, be like, I don't know what to put in here. I don't even care. Well, luckily, I took the time. I took the time to figure out what the happy path is for everybody, so you don't need to. And all of these are same for everybody, so you just forget about it. Um, uh, it also needs IAM roles to be able to execute. It needs the policy. It needs trust relationships, a whole bunch of like if you were doing this by hand, you'd have to go do a whole bunch of stuff in AWS IAM, read the docs, and the docs on AWS are terrible in this regard. Um, and they have to create the Lambda function, and then you have to do you'd have to do your Docker build, and then you have to then go create your Lambda function and say what it is. And then you have to go connect. You have to go set up more policies on the Lambda function, and then you have to go add the URL. And then in this case, since you have to deploy it to since you have to deploy it connected to EFS, you also have to give it a network interface or a public IP. It's like all this stuff you have to do to just like it would take you forever just to run these 9 lines of code. And then specifically in this case, where the machine learning stuff gets uncomfortable is downloading something like GPT-2. Let's go look at that on OpenAI. Files and versions. And this is going in here. Oh, great. Look at this. It's 1, 2, 3, 4, 5, 6, 7, 8 files that all exceed a couple gigabytes. And it's like, oh God, what am I going to do there? Where am I going to put those? And so that's where the EFS mount comes in here, is you can specify a file system. And I created this earlier to speed things up, but to create one, it's just a couple click buttons. And it will mount this at /mount/cache, just like that. You can see the name is the same there. And then and basically it when you do this, it sets that up as your cache home. So when you do a Hugging Face Clyde download, I dug into their source to figure out how they do this and how to configure this. Is when you do a Hugging Face Clyde download, it will download to wherever your OS's cache directory is set as, and set that there. So this invocation here didn't actually run on your computer. It didn't actually run on your system. It fired up the Lambda function and ran it. So let's hop on over to, let's actually have some fun here. So it finished, and you have your URL. And once again, we're trying to get to the level of this deploy where we have our own API. Oh, hey, look, we have a URL on AWS. There it is. I'll post that in the chat so all you guys can try, so I'm not, I'm telling the truth. Where is my Zoom chat? Hit it. So let me,
Could you post a curl in there so we could hit it?
or you hit your browser, or whatever you want. Curl also works.
All right, I hit it with the browser.
Both are fine. It's just a Flask API endpoint, so anything will work.
I'm still waiting for a response.
Yeah, so a big note on this is this isn't a great way to run these models at scale because the their Lambda is still only CPUs. They don't have GPUs. These models obviously run a lot better if you have a GPU backing them, but it's a really good way to do it. However, the way I've configured, like Lambda, historically they've shot your requests in the head if they take longer than 30 seconds. They recently introduced a feature where they allow them to run for up to 15 minutes. So you can actually just let this run. So if you actually do have long running HTTP requests, it works fine. For anyone that ran it, did it work for everybody?
Yep.
Yeah, it worked
Eventually?
fine too.
Like 15, 20 seconds. Now, if you run it again, it's going to be a lot quicker. The reason it was slow that first time was basically that first boot. But then also these machine learning is running on the models running on CPUs is not great. But this is a really, really good way to get a model up and running in Lambda quickly. What we can also do is the way Lambda works is the more memory you give it, the more memory you give it, the more CPUs it gets. So let's go. I know I've gotten hit here, so I'm just going to give it 3008. I can't remember if my account has pinned at that or not, but I'm just going to do it. Most Lambdas you can go up to 10.0240 or no 10 gigs. And so this would probably be about 10, I believe in AWS Lambda, so CPU scales with memory, so this would probably be 10 gigs and 4 CPUs is what you can do. I put in 3008, so I believe that's 3 CPUs and that. And by default, it's 1024, which is one CPU and, or sorry, half a CPU and 1 gig of RAM. So let me hop into AWS. I'm going to show you a few layers what's going on here. And Woody, if we're getting close on time, let me know. I can shut up.
I'd say it's more up to you, given you're in Eastern time. So if you want to keep going, by all means, let it rip.
I'm pretty close to the end here. I just show a few layers on how things work. If we go look at the Lambda function, we have SciPy. I have so many. There we go, SacPy GPT. You'll see here that in the configuration, it is tied into the big ones that we care about here is that it has a file system mounted at mount cache. We have a whole bunch of environment variables that have been wired in that allow you to use them or not. It has set up it's set up an alias to with a function URL here, and this is where this came from. And with that, and it also does versioning as well. So if you need a rollback, it's pretty simple. It sets up all the permissions that you need, and a whole bunch of good stuff. So I'd love to nerd out with all of you on kind of how this works. If you're interested in trying it out on your own, I have a couple options for you. If you ever worked in the or if you ever worked with other new project tools, let me clear this. I've made you can do npx scaffoldly create app and with template Python Hugging Face. Let me go back to here. npx scaffoldly create app with template Python Hugging Face. It'll ask you for what's your app name. So I'm going to call this Woody GPT, and it'll give you a few instructions here. But let's take a look at this. It's very similar. I've set up this is the brand new project that is available. Basically sets up your code foundations, the exact same thing I just showed you. So a one-liner to get to a project with this also adds all the configuration that I was showing you earlier, where it's running on Python 3.12, sets up the file system, pre-downloads the GPT model, runs the app, sets the memory, all this stuff. So you don't have to worry about it. So you have one command. And so if I wanted to deploy this, I basically do npx scaffoldly deploy, and Woody GPT is about to be up and living. And
Oh, yeah.
Yeah. Um,
So this creates the Docker container, uploads the Docker container to the AWS ECR, and starts it running on the ECR.
it says, oh, sorry. Let me show you that part of Lambda is it says somewhere here where it says, where do I want to pull my code from? It sets up this, it says pull this image.
Okay.
And so if I go over here, if I go to repositories, you'll see Woody GPT repository is this here. You'll see that come up here. Let's do the SacPy GPT. And here you can see this image, and you'll notice that this is the image that's actually running up there. And then every single time you do a build new image and stuff like that, 500 megabytes in size, that's your code and your VM all together. And yeah, pretty good. And just to cure the skeptics out there is I use this for everything I do now. Is I just launched this morning. Uh, Nuss.io slash API. It's a Next.js application running in the same thing. And so you could see that latency there of how long the response was about a second. But look how fast the subsequent ones are. And this is a full round trip from my laptop to AWS to a container all the way back. And it feels just like a normal API, super responsive. So you can write fast API, you can write fast stuff, you can write slow stuff, doesn't matter. And and now it's serverless. And the only thing I paid for was that 23, 25 milliseconds it was actually running. And now I'm paying for nothing currently. And now I pay for 25 milliseconds and nothing.
Your X account looks like you're debugging at that moment.
So yeah, I think that's the end. So here is a few links that I'll put in there. Is first my blog post that started this whole thing that Woody and I connected on, and then Scaffoldly examples is a great place to go. Let me just show you that really quick. I've taken this concept, and not only it's Hugging Face machine learning models, is you can run it in the exact same way with Golang, with Node, with Express.js, with Next, with Python, Flask, Poetry, or Rust, or whatever. I've run WordPress like this, which I haven't advertised that, but I'll tell you guys because I trust you. But theoretically, we can run PHP serverless this way. So other links that we have, the project that I built today, feel free to pull that. And then also the commands to get started were those. That's everything. Any final questions?
All right. Well, thanks again, Christian. This was pretty awesome. I mean, AI is crazy and got an idea, serverless. Get the whole, oh, you want to make an apple pie? First, create the universe.
Create an oven, and then you can create an apple pie.
Yeah, exactly. No, let's just get to pie.
Yeah,
Sweet, sweet LLM pie.
right.
I love it. All right.
And
Well,
yeah, thanks for all the questions, everybody. I have a Discord channel. It's on it's the links to it are everywhere, but let me grab it really quick. But if you guys want to nerd out on this stuff with me, if you want to help out, or if you kick the tires or have any personal projects, if you're cash strapped and don't want to spend a bunch of money, hop in and let's play. Where is the chat?
Yep. Definitely want to nerd out.
yeah. Dr. Flask, aka Bobby E. Robert Edisham is a convert to Discord. I love Discord.
Yeah.
I'll be on there. I apologize in advance. I will try not to spam you.
Yeah.
I'll stay on
This
top
is
of
really interesting because you're going into the guts of working with Lambda.
Oh, I got way deeper than I liked.
Well, that's good. That's why you get to be the trailblazer.
Yeah. The one things I haven't figured out yet are like local dev that feels like serverless. That's probably I'm not going to get into the weeds on that one, but and also the other thing is like streaming technology or persistent connections like WebSockets don't work, unfortunately. But most of everything else does. If my general rule of thumb is that if it HTTP 1.1 supports it, I can support it.
All right, we just doubled the Scaffoldly Discord server
All
population.
right.
Go.
Yeah. 100%.
Could you use that? No, you could not use this for training an LLM. This is just for running a pre-existing LLM.
Yeah, but I assume like with let's say you have a Jupyter notebook open and you're retraining and you have a Jupyter notebook and you want it, and at the very end of the notebook you basically do a Hugging Face push, for example. I assume that's what the command is. Never tried it, but I assume
Uh-huh.
it's a Hugging Face push. Then it's up there. And let's say you make it public or private. This also took the HF token and runs it in the container, so that it actually is running downloading the model using my private token as well. So it supports secrets coming from your system and stuff.
Sweet.
Christian, can I get an unexpiring link for the Discord to put in the YouTube
Oh shit,
recording?
did that? That is
Is it infinity link?
it's an infinite one.
Okay, great. Cool. All right. Well, I think I got most of the links. I'll put them in the recording.
Great.
Well, this is great. Man, dude, I'm getting close to like launching the first module of the Red Eye game, and I think serverless might be the way to go.
Dude, try it. Like write your API in Flask and use Scaffoldly to deploy it. Your mind will be blown. Be like, hey, did I just write an app and it's costing me 12 cents a month to run this? Okay, cool. I think I'll write a few more this way.
Yeah, yeah, exactly. Yeah, and then I want to take the modular approach. So onwards to the next.
Yeah.
Hell yeah. All right. Well, thanks everyone. Yeah, get on his Discord. I'm in there. I'm gonna post so
Cool.
many memes.
Yeah, I'm desperately looking for people to kick the tires and give me some feedback. I've made a lot of decisions, a lot of opinions, a lot of solutions that I know that I want. What I really, really want is other people to really, really push the limits and let me know what they want to do. This whole thing came up because one of my contacts wanted to run Next.js in serverless, and I hit those size limitations, and that's where this entire snowball started.
Awesome. All right. Well, get on it, people. But I think that's all for tonight. We'll see y'all on the next one.
Cool. Thank you.
Right.